Hello, this is GEFerris. I have put together this compilation of photographs and videos of the suipiaq alutiiq kayaks that are on display in Kodiak, Alaska. I also have included photographs and videos that I took in 1992 when I was visiting Greenland. One of the most important sources of information was that moment when I was in Greenland in 1992. This is John Heath from Texas. And I'm GEFerris. We're in Greenland.
O.C. Peterson. Nuka.
I can see you going back and forth. That looks good, Nuka. Oh, that is excellent.
Yeah, so it's
like a rocking horse.
Yeah.
A kayak shape, just perfect.
Yeah. Well, the ones who start the first time to get a feeling of how it feels. But
Yeah.
It's just a little more extreme.
Yes.
It's just to sort of get people into focus, so to speak.
I videotaped this baidarka frame at the St. Herman's Monastery. It was on display, hanging from the ceiling. It is one of the many baidarkas that was constructed some years ago and has been restored to a certain extent. There are various things that are different about this particular frame. Looking at this bow piece, it's just amazing to see how vertical it is, and so is the stern. And it is to prevent diving and have a volume that is widened out enough on the top to really offer that security. The shape of this bow, especially the top of it, is not meant to be a grab handle because these kayaks were not used among ice to speak of. They were used out in open water. The gunnels are winched together with a Spanish windlass, and everything is mortised into these gunnels but not pegged in so that things can move. It is all tension just to stay together, but the pieces are able to move to a certain extent, with the exception of the deck beams, as you see in this picture. What's of great interest that makes this boat as flexible as it is that all of these ribs are simply just resting in mortised hole in the gunnels, and they're all tied in with just plain line or sinew. Only the deck and cockpit are rigid in this kayak. The dimensions of these ribs are so slight, and also of the stringers, and they're just simply crisscrossed over each other. Nothing is solid in this hull, but it is just designed to stay together but retain its seaworthiness. This cockpit lip is meant to just be totally stable because it is stabilized by being attached to the deck beams and on the sides to the gunnels. The cockpit lip is especially designed to be part of the entire boat. The paddler can use this cockpit rim as a direct source of leverage of the craft while it is underway. The deck beams are meant to be a rigid, stable platform mortised into a stable configuration with the gunnels. They are meant to stay where they are. You can tell this by the long rectangular mortises that feed into the gunnels. This is not meant to move. The deck is meant to be a stable work surface platform which can be relied upon for holding tools, especially harpoons. The kayak paddler can stabilize his body weight as he is stepping in and launching this kayak. However, oppositely in design, complete antithesis, are these elliptical shaped stringers and ribs that intercross each other at approximately 90 degrees. They are meant to shift and change shape as the demand of the surface of the water places upon them, making this kayak a very, very seaworthy but highly flexible structure. This kayak responds to wave shapes by changing its shape underwater. Meanwhile, the whole structure is stabilized by the gunnels and deck beams. So when you're paddling, it is responding to the seas in ways that reduce surface friction drastically. The skin covering is soft and flexible. It's probably sea lion skin. But what happens with the skin structure is that in the water it becomes flexible and develops voids in between all of the stringer and ribs, such that it reduces all of the frictional surface area to the water. That dynamic surface flow is constantly changed such that it isn't concentrated in a huge area. It's broken up so that the weight of the boat itself gives it great speed and the shape of it, because it reduces surface friction enormously by having all of these little hollows and voids that are constantly flexing in the seas. Likewise, the small vertical stern helps reduce the problems that occur with friction behind the stern. The hollows are most important in helping this boat become a fast boat, and it's constantly changing in its shape. The stringers are attached to the bow piece by a single point and to the gunnels by simply being lashed with very simple knotting that just keeps everything together, oriented vertically with the gunnels. It's just a means of keeping everything together. And then you can see these weird looking ribs. Yeah, they keep changing shape because they are so flexible and they're so loosely tied in. They can change with the seas as necessary. The boat is actually self-fairing, which is quite exciting to think about. Not only self-fairing, but constantly changing with the seas, which is always a different shape. So these knots and lines are very simple means of a non-rigid way of attaching these ribs so that they can shift around along with the stringers that are shifting and weaving with the seas. Here you can see these distinctly elliptical shaped cross pieces, the stringers and the ribs. That is meant so that they can change shape as necessary. The other thing that's so fascinating is that the ribs are just loosely mortised into round holes in the gunnels. They can shift and move as necessary. There isn't a rigidness to the structure along the hull. Looking at these sturdy deck beams mortised into the gunnels and looking at the simple round mortise holes for the ribs, it's amusing to think as a paddler that at least the deck is stable forward and backward, side to side, but everything below is moving around. It's something to think about. Boy, this was a guessing job. These gunnels were carefully planned in dimension to be just stable enough to keep the boat going in a straight line. But after that, all bets are off. The boat can move up, it can move down, and with the shape of the water, but it'll keep going in a straight line. And looking at these ribs, some of them are tied into the mortise holes on the gunnel just to keep them from slipping out of those round holes. This information I got from Kayaks of Alaska, written by Harvey Golden, and my own personal experiences of paddling things slightly similar, such as a two-man Arius 2 Klepper with a slightly deflated hull gives somewhat the sensation of paddling in one of these flexible baidarkas. If you think about what happens when you step into a cockpit, that's why these little pieces are all tied together to the gunnel, because you don't want to have everything just sort of drop out from under you while you are trying to get underway. The whole idea is to keep this dynamically and structurally stable so that you can get in there and launch. And the other thing that goes with these boats to make them seaworthy is to put some rock ballast in behind the cockpit. Not in front and not way aft, but in the middle of the boat. And as you catch animals such as sea otters and seals, and you can switch out the rock ballast for the weight of the animals you have caught. Just a neat idea. Everything is inside the boat. It's not carried on the deck when it comes to hunting quarry. It's all inside the boat, so you can just paddle along without having to worry about things washing off the deck. And by carrying your hunting quarry inside the boat, you don't have to worry about the effects of changing your center of gravity. That's not a nice thought in a kayak. A little weight in the bottom is very convenient. You want the bottom of your kayak ballasted with something. When it's this perfectly round shape, you need to have some kind of ballast for stability. The other wonderful trick with ballast is you're getting rid of your windage. And the trick is also reducing your visibility to the animals you're hunting. And that's just a great idea. You don't have to worry about things washing off the deck if they're not on the deck. So this whole flexible platform for hunting is also stable so that you can throw a harpoon or shoot a rifle without suddenly taking a bath. I find it very delightful that these ribs are automatically self-varying because they can just shift around in the seas as waves press them. The shape and the volume of this keelson is just enough to provide a surface to prevent longitudinal friction from building up and to keep the ribs from going places. It gives a surface that allows the boat to track somewhat straight. Looking at this keelson, if you imagine that it is covered with flexible skin, what happens is you get shapes that are broken up and the whole boat is stabilized directionally. Otherwise, without a keelson, you'd have a royal problem with protruding rib shapes. So it's just simply tied together with line, just to keep everything in the right direction. Here is a picture of the ribs as they are just simply slipped into round mortise holes. And wherever there is line used, it is meant to stabilize in the second direction. Instead of back and forth, it stabilizes things up and down. So you have two-directional stabilization. There's no place on this kayak where things are doubly pinned to stabilize them. That just is not practical. Tying things off with line and sinew is the most flexible way of integrating this boat with the water. Repairs on these ribs are simply done by binding them together with line, sort of whipping them off. The ribs are probably willow, and the stringers are probably hemlock. It's hard to say. All of the wood in this kayak is most likely either driftwood or milled lumber that was available at the time when this boat was built on Kodiak Island. This bow piece is a single piece of driftwood, and here is how it is all attached together, the various pieces, the gunnels here in the top and the stringers, and how the gunnels are tied together with a Spanish windlass, how the ribs are tied so that they can't slip out of their mortises, and how the ribs are stabilized with a string around them so that they can't shift up and down very much. For a cracked rib, the only kind of repair you can make is to just simply bind it over and over and over and then tie it off. It would be absolutely impossible, because the ribs are so tiny, to make any kind of splice. Here you can see that the ribs are just simply rounded up on the ends and pushed into round holes in the gunnels, and they are not really forced in all that hard. Also, you can see the square holes protruding through the sides of the gunnel, which are for the deck beams. The other thing that's interesting about this gunnel, you can see it's been spliced in this one spot where it evidently cracked. Here you can see where the deck beams have just simply been mortised right through the gunnels, and they are designed not to move. They are long rectangles. Here's a splice spot on the gunnel. The gunnel is more than one piece of wood, which is quite typical of such a long piece of thin wood. It also gives flexibility to the gunnel. Scarfing the gunnel together from multiple pieces of wood gives you a better, straighter grain and more flexibility. Here on this piece you can see two nails have been used in this gunnel, sideways. Interesting idea. There's a scarf underneath. Running down the gunnel a little farther, we can see another spot or two where some nails have been used to secure various places. I just don't know why they are used, but there are some nails. Now we are looking at the kayak from a distance. Actually, this kayak is missing one of its cockpit hoops, and it is a two-man kayak. This is just an overall view I took with my video camera, panning along to show you the general disposition of the keelson and the stringers. And there you have it, this wonderful two-man baidarka, which is at St. Herman's Monastery in Kodiak, Alaska. Here I am in the Baranof Museum on Kodiak, Alaska, and we are looking at various suipiaq, alutiiq kayak models. These are wonderful models, and behind this is a photograph that shows these particular baidarkas in actual use here in Kodiak. The design of this baidarka was specifically for hunting and traveling long distances, but to be built quickly. Here is a drawing John Heath has made of the next baidarka that is at the Baranof Museum. Because of the seaworthy reputation of these particular kayaks, I was most interested in visiting Kodiak. I had spent time with Corey Friedman as he showed me how he built this design of kayak, which is interesting to think about. Here I am looking inside the cockpit and taking detailed pictures of anything I could see with my camera, just so that there was a visual record of all of the details my camera could see. I am seeing the edge of the cockpit lip and then the crosspiece with the different shapes involved, the types of wood used. The ribs actually have bark remaining on them. I've also seen the same idea in Greenland with the bark left on the ribs. Here is the crosspiece again, the front part of the cockpit, and showing you how it was attached in this particular baidarka. That makes it even more fascinating rather than just looking at a dry drawing. How did they actually expedite the shape of this boat? Interesting thing is that there are pieces of wood along the ribs to smooth out the surface of this boat. Here is the previous baidarka, and you can see no, there are no flat stringer boards. The stringers are rounded. In this Baranof Museum boat, the stringers you can see are flattened, wide, little slats of wood. Looking again at the Baranof Museum example, this is the lip of the cockpit, how the skin of the boat is attached to it with lines of sinew or string, depending on what was available. This is the interior of that area around the cockpit. Here are the boards on the bottom, along with stringers over top of the boards to add more strength to the boat where someone is going to be stepping or cargo may be carried. These are the ribs that have shrunken down and broken. This is the bow with some stuffing in it, original, for some reason to keep the volume and things from getting lodged in the bow. Now we are going along the ribs, you can see here, and here you can see rounded stringers up in the bow, the more traditional rounded stringers, along with the keelson. Right around immediately in front of the cockpit hoop are boards on the floor of the kayak to prevent things from projecting into the surface area of the skin that's covering this boat. You don't want heels poking out or anything that might cause damage to the skin while this boat is being used, especially during launching off of rocks. Here is a scarf in the keelson This is toward the bow, and notice the orientation of the scarf. This is to give flexibility to this baidarka.
Ribs are surprisingly thin, especially considering this boat is 25 feet long. But there certainly is an equally large number of stringers. They're both of equal width. That's very interesting. It must have been a very flexible feeling boat to be in.
This is all I found of how the skin is attached to the structure of the hull.
This is the skin covering from the third cockpit facing to the bow. The skin is covering the bow, and then it is drawn up around and then stitched together along the peak of the deck. I don't see any structures inside of this kayak that draw the skin together from within. So these ribs continue in the same character all the way down. And you can see the first stringer is tied to the gunnel. And the cross pieces of the deck beams. Are mortised in and then tied. Actually, yeah, that's tied to a deck beam. The stringer, first stringer. And that's held up. So you can see this tie. There's I don't see any pins here for what we have for the rib to tie into the gunnel. That's interesting. And the dimension of the gunnel is about 2 inches by 1 inch. So the ribs are continually lashed one side to the other, and then it goes back over. Equalize the lashing pressure directions. Also, the particular geometry of the paddle is entirely different than what you see in Greenland. Pedals are 8 to 9 feet long, I would estimate.
The ridge down the power face of this paddle is to split the vortexes in two during the power stroke.
This shows that the first part from the bow to the first cockpit was sewn and then slid on like a glove.
Here is the bow in detail as a bunch of photographs, and I am running down the deck just to show you what it looks like as far as its general disposition. A lot of the skin is split open, but here and there it's interesting to look at. Here's another cockpit and its details. How the skin is just simply drawn up to the cockpit lip, tied off. Here is the paddle. Here is a general view of the deck. Here we have a detailed picture of the cockpit lip and how it's tied onto the frame of the baidarka. The scarf joint on the cockpit hoop, how it is attached together in a couple of places, and then attached to the deck members below, and it's attached with pieces of sinew in this instant. Here is the deck. Obviously it's inverted, but this is what the deck looks like. Some minor details along as far as condition of the skin. I suspect it's sea lion skin. And this is the paddle with that wonderful flute right down the middle. I would guess that this paddle was scraped with something like glass so that it wouldn't drip water and make that noise to alert everything around that there is a kayak on the water. That's a trick I learned up in Kuslauswak, Greenland from Nikolai Jensen. What a wonderful paddle this must have been. Imagine this paddle being used for this boat. Just imagine what it takes to move a 25-foot, 3-man baidarka fully loaded. You would need a paddle of this surface area and design so there wouldn't be any hesitation in your forward stroke. You would want the whirlpools to come off on both sides when you're driving the paddle through the water. The worst thing in the world is to have a paddle that wavers back and forth from side to side. That would ruin the whole effect of developing power in your forward stroke. Now I am moving on to the Alutiiq Museum in Kodiak, where I am talking with Joe Kelly.
I'm here in the Alutiiq Museum, and we are looking at a reproduction kayak that Joe Kelly supervised its construction of. What I'm focused on is the bow. The grain follows the shape of the bow as close as possible for strength. It's difficult to find just the right piece of wood. This is the most difficult piece in the boat, correct?
Pretty much, yes.
Yeah. Guess you have to do a lot of guessing.
Your deck beams also are from similar pieces of wood that follow.
These deck beams are, in this boat, made of what?
All of this boat is made out of spruce.
Okay.
Originally, the ribs would have most likely been made of alder. And we chose because of the expediency to use spruce, but alder would have probably been the wood of choice in the original boats because it would have been selected and bent, shaped and bent green.
Now, this bow piece that we were just looking at is, you said before, it's pegged in?
That is sort of like a truss system. You have your keelson, which utilizes a scarf joint, is lashed in.
Yep.
Your two gunnels come in and are lashed into this socket.
Yep.
You have your two bottom stringers that are located into a notch and give it flexibility from side to side. They catch it. And then you have your bow plates, which run, that are located into a notch and give it flexibility from side to side. They catch it. And then you have your bow plates, which run gunnels to your bow piece. They're pegged and also lashed. We used rawhide, but most likely that would have been sinew or spruce root. Spruce root was used many times.
I noticed that the stringers are carefully fared in so that there's no bumps in the surface of the boat where they feed into the bow.
Right. Although this section would probably, unless they really were sticking out grossly, The skin
Yeah.
would be
With, yes, that's
the
right.
bottom, the lower stringer is of course important. The other two could be a little less careful maybe, but I think they were put in there sloppily anyway.
The other thing, there are surfaces on this to accommodate the fact that the skin must be able to dry easily, so that, that's the reason for these grooves, is so that air can pass over this when the boat is out of the water, so that the skin covering will dry.
It's likely.
Because that's critical, otherwise it rots out. To tighten these ties, you go around several times, and each time you pull up as hard as you can, and then finally you would knot it off.
Well, like this major lashing that lashes the bow piece,
Mm-hmm.
the string or line would go in here,
Yeah.
down around under the keelson, back up through the other gunnel, back through, and which would form a V from here down to here.
Okay.
Of course, that's put on before your stringers.
Yes.
So you've got basically a V, and you begin wrapping. And as
Yes.
you wrap, you tighten this together. You get
Yes.
rid of the V, which is essentially is like a clamp. It tightens in,
Yeah.
puts the V in, and takes up any
All that
slack
slack.
that you might have had left in there.
That's
That was a real
incredible.
common thing to see done on kayaks, and it's a common thing to see done on things that might be lashed in that era.
Now, along the top of the gunnels, there is a plate. It looks like a plate, this piece. Now this, I gather, would be to add volume to the bow in big waves.
Well, that's one thing that it would do. The other thing is it ties the gunnels, the keelson, and the deck stringer all together. These are part of that truss system I was talking about earlier that really add rigidity to the bow.
Yeah. Now the deck stringer, I find this fascinating, that it goes and it follows the curve of the bow exactly, all the way to the very tip. This I've never seen before. And I think part of the reason is, first of all, to let some air in, and second of all, to give structural integrity to the bow.
Yeah. And the alutiiq name for this piece, I can't remember it now, but it essentially, literally meant the thing that you pick it up by or the thing that you hold it by.
Aha.
They had just been made for a simple function of carrying the boat.
These ribs are mortised into the gunnels.
Yes. It's about 30 ribs on this kayak.
But it's designed so that the deck flexes a little differently than the bottom,
Yeah.
which would affect its character in the seas.
When you build a boat upside down, you basically put the gunnels, the deck beams, the bow, the stern together as a unit. Flip it upside down, and then you start adding the ribs. Once the ribs are in, you add the stringers, and then you begin to lash it all together.
I think one thing that's important about this boat is that it's built to take many different types of sea conditions and absorb them each in the same way. So you can have a small sea where this bow will, with a lower section which is meant for little waves, and then you have the increased buoyancy of the upper section of this bow, which is wider. The small seas act on the bottom of the hull, which is the most flexible part. And then when you get into larger seas, the gunnels start absorbing the wave stress, so that each part of the boat flexes with the kind of sea that it's in. And what I mean is, the larger the waves, the different parts of the boat flex differently, so that you're getting a boat that integrates with the water.
Well, no one can look at these boats and help but realize how technologically capable the people were who put them together and survived in a situation that people have a hard time surviving in with all kind of technology.
Okay.
The skin's not laying flat against it. It also may add strength. Just
Yes.
like putting ridges in your corrugated metal, adding strength. This, of course, is sort of for your skirt to tie around. This lip.
Is that a scarf underneath? Point on
It
midship.
should, yeah, it's not a locking scarf, although I've seen them use different kinds of scarf joints.
Yeah, yeah. This is a slightly oval-shaped cockpit.
Some of them, many of them are. I've seen both. The larger boats tend to have round hatches because when you're kneeling you don't need as large a hatch. And so this may not be totally correct. That's one detail that has been hard to verify. The larger boats that we've seen though do tend, but there's almost no documentation on the single. We're a little unclear about the exact hatch dimensions. With the oval hatch you still have more volume, but you don't take so much of the width of the boat away. But if that were a larger boat, I would say that it probably would be round.
Okay.
One of the doubles or three hatch. The single hatch boat was called kayak, which meant lone. Kayak puck was the double, and pactalic was the three hatch boat. So they all three had different names. All three were kayaks,
But
had
different.
specific names.
The ribs, I was just noticing, are not just lashed in one direction, but to equalize the pressure, they lashed them in the opposite way also. And you can see they cross over one way and then they crisscross the opposite way, which would make sense to sort of keep things from moving. I think the most simple part of the boat is actually the stringer on the deck. The stern is rather interesting. This is curious because the keelson extends completely back.
And I've seen different ways of doing this. I've seen this piece be one. That this piece, the stern piece, actually is part of the keelson. There'll be maybe 3 or 4 feet out there be a scarf joint, and then maybe there are some models that I've seen where the bow piece actually had a piece of the keelson as an integral part, and maybe came 3 feet or so past it, and there was just 2 pieces, one from the bow, one from the stern, and then there was just a short. So anyway, I've seen both. I've seen models. There's some archaeological models that we dug in Carlock that show the bow piece with a long elongated piece on it, like that. And that's over in the Baranoff, and then I've seen it where this is several times. I think I've actually seen a full size to where the keelson is part of the stern piece. Now this is actually a mortise and tenon, and it goes back in here, and there's a tenon on this deck stringer.
That has to be quite tricky.
So, and then it's lashed in with sinew or spruce root into this.
Okay.
And like most of it, we peg this with 3 different pegs. Usually pegged wherever the sinew went through, they would peg it just, I guess, to make sure it didn't unravel.
Backslide, yeah.
So the whole thing was pretty well thought out, very well thought out.
I'm looking at these deck beams, and I think it's interesting to me I notice that they're wide one way and then wide another way. They're very carefully chosen. The shape is wide where the stress is going to be.
Where they trade off width in the horizontal plane,
Yeah.
they gain depth in the vertical plane. So you end up with about the same mass. And right here, it's probably more functional to have more depth in the vertical plane for this.
Yep, because the stretch is going to be that
Then
way.
it phases into a narrow in the vertical plane and wide in the horizontal to make the transition for the tenon that goes into the gun. It's an interesting thing. I remember one of the owners telling me in the double, if you're paddling in the stern, you're having a hard go of it into the wind.
Yeah.
Keep it in. As you can imagine, if you've got quite a few feet of kayak in front of you, trying to keep that straight into a quartering wind can be real difficult.
Yes, yes.
So they would do a maneuver where they turned around in the hatch.
You're kidding.
It's called kayak, thing like that, and they went in for in. So they would turn around and paddle the stern into the wind. And then you only had 4 or 5 feet to control and 15 feet out in front of you to manage. So you can imagine the leverage was, you had a lot more control of where your boat went.
That would also explain why your deck height from bow to stern is the same. But yes, this could be, you could reverse paddle this.
Well, another way to look at it, you've got 2 options in building the boat. You can have a deck with a lot of shear in it, or you can have a bottom with a lot of rocker in it. It's hard to get both. You know, trade off one. If you build rocker into your boats, you're going to end up with a pretty flat deck. If you build a pretty flat keel, then you're going to have a lot of shear in your boat end to end to match that. So it's hard to get both. You notice there's a lot of shear in the deck and a real flat keel. So we looked at the pictures where I did, and I said, this isn't right. No other kayak looks like this. So went from that generation to something that looked quite a bit like this.
I have found that a boat with rocker is much more kindly in steep waves. So this is just to show the amount of rocker this boat has. And the nice thing also is the curve of the bilges here is a very soft, subtle, elliptical shape.
Yeah, that also is very tender.
Yeah, but in big seas it would stiffen up. But in really flat, calm water it would be tricky.
It's a high volume boat.
That keelson looks like it's almost 1.5 inches depth.
Yeah, 1.25 inches.
Your stringers look like they're about 3/4 of an inch.
3/4 to 5 inches. And the real ones were probably about a 1/2 inch.
Yeah.
Realistic. 1/2 inch to 5/8. Those are a little bit beefier than they originally were.
How about your gunnels, that thickness of gunnel? Do you think that was the more typical dimension?
Well, from the smaller kayaks, yeah, because I've seen some from archaeological sites who are about that same size.
So the dimension of that gunnel looks like it's about
It's about an
inch.
and a quarter
Yeah,
by 7/8.
7/8. Yeah, so much different than any Greenland boat. They're entirely
Oh, yeah.
gunnel-dependent structures. Whereas this
It's
is,
got all those ribs and
yeah,
stringers that act as part of the structure. You don't need such a massive gunnel like the Greenland.
yes, yes. How are those deck ribs? They're mortised through the gunnel, and oh, I see. They're tied. They're tied off.
Yeah, and you've got about 3 different angles to consider ours for a skilled builder in putting this little boat together, the frame.
Yeah, to figure out the shape and the angles on those mortises. Each one is. Yeah, that's not easy.
I've done it by hand, and I've done it after I did a few. Then I wrote down the dimensions and the angles for each one, and began to use a drill press and mortising tool.
Yeah.
And then I could calculate all my angles at once. There's about a 9-degree slant here, so many degrees slant here, and then an angle that it comes through the other way. So there's 3 different angles to consider anytime you drill.
Yeah, and each one is different. Oh boy.
And they change, yeah, right.
Yep, as you go down the boat. Yeah. So it required this, really the skills of someone who was very good at carving.
Yes. And had a good eye, because all the ribs, that's strictly visual, and those are all put in there. Those are put in there with just visual reference for symmetry.
And they're also spaced for where they feel there's most likely to be a lot of deck stress. Now you see closer to the cockpit, you have the ribs are closer. And then aft, where there's going to be less weight and stress on the deck, there's a larger space. It's a beautiful boat.
Yeah,
I want to thank you very much.
that frame was built by Bud Roselle from Akiak. He did most of our construction while we were in the project.
It's
Beautiful
amazing.
work.
Well, thank you very much. This is at the Alutiiq Museum in Kodiak, Alaska. This is the skin-covered version of this same boat we've just been discussing. Just out of curiosity, note that the bow has a hollow in it, and so does the stern. That shears off the bow wake and stern wake. Also, the harpooner is just balancing the kayak with his body. He doesn't need to balance with his paddle. In this picture, a gentleman is demonstrating how this boat handles in a fairly windy situation, actually. And in a moment, he's going to swing around, and you can see how much of the bow actually is in the water when there's only a person sitting in it. Very interesting boat. This is GEFerris. Thank you very much for watching my video. I had a great time in Kodiak gathering all of this information, and I can't thank everybody enough for allowing me to gather this information.